All right, today we're going to dive into a tiny, tiny component that is just absolutely critical to the fast, efficient electronics that, let's be honest, kind of run our world. We're talking about the Schottky diode.
Have you ever really stopped to think about this? It feels like it shouldn't be possible, right? We want more power, we want more speed, and we want it all packed into these tiny little devices. But they don't just, melt. How does that work? Well, it turns out there's a little bit of electronic wizardry going on behind the scenes. And the solution isn't one giant breakthrough, but actually a whole bunch of really clever innovations working together. And one of the most important pieces of that puzzle is a special high-performance component that's probably in dozens of the gadgets you use every single day. And here it is. Say hello to the Schottky Diode. You might also hear it called the hot carrier diode, which is a pretty cool nickname we'll get into in a bit. But this right here is the unsung hero of our story, and trust me, it has some serious superpowers. It really all boils down to two main things that make the Schottky Diode such a total game changer in electronics. It's incredibly efficient, and it is unbelievably fast. So let's break down that first superpower, efficiency. So it all starts with something called forward voltage drop. The easiest way to think about this is like a tiny toll that the electricity has to pay just to pass through the diode. For a standard, run-of-the-mill diode, that toll is about 0.7 volts. But for a Schottky diode, it's way less than half of that, only about 0.3 volts. Now I know, that sounds like a ridiculously small difference, but in the world of electronics, the implications are absolutely massive. And here's where that tiny voltage difference blows up into a huge deal. That little voltage toll gets turned directly into wasted energy in the form of heat. Just look at this chart. If you're pushing a serious 50 amps of current through these things, a standard diode is going to waste 30 watts just making heat. But the Schottky diode, only 15 watts. That's a 50% reduction in wasted power. That is exactly why our devices can run so much cooler. Less waste means way more efficiency, less heat you have to get rid of, and that lets engineers design things that are smaller and more powerful. It is a huge, huge win. Okay, so it's incredibly efficient. Check. But that is only half the story. Its other superpower is just pure blazing speed. And in the world of modern electronics, speed is everything. See, at really high frequencies, we're talking about switching on and off thousands upon thousands of times a second, a normal diode just can't keep up. It's too slow to turn off properly. It ends up letting current leak backwards, which can cause the whole circuit to just fail. The Schottky diode, though, it switches almost instantly. It's clean, it's reliable. It was basically born for this. And this incredible speed unlocks technologies that are absolutely essential today. You know the power brick for your laptop? That's a switched mode power supply, or SMPS, and it works by switching at super high frequencies that only a Schottky diode can handle without melting. Same thing for high-frequency radio parts and sensitive signal detectors. These things literally wouldn't work without it. So how does it do it? What's the secret sauce that gives it all this speed and efficiency? Well, the answer is in how it's built from the ground up. Its construction is fundamentally different from a standard diode. Okay, so a standard diode is made by smashing together two different types of semiconductor material, what they call a p-type and an n-type. A Schottky diode just throws out that whole idea. It gets rid of the p-type material altogether and instead makes a junction between a piece of metal, like platinum, and the n-type semiconductor. It might not sound like a big change, but it completely rewrites the rules of how it works. Right, and because of this special metal semiconductor junction, the flow of electricity is carried by just one type of charge carrier, the electrons. This makes it what's known as a unipolar device. And that is the key to its speed. Why? Because it lets the Schottky diode completely avoid a huge problem that slows down all the other diodes. And that problem is something called reverse recovery time. Just think of it like a braking delay. When you tell a diode to switch from on to off, it doesn't happen instantly. There's this tiny little delay before it actually stops conducting current. And obviously, the shorter that delay is, the faster your diode is. So here's why that delay even happens. In a normal PN diode, when it's on, you get these charge carriers that cross over to the wrong side of the tracks, so to speak. They're called minority carriers. And when you try to switch the diode off, you have to literally wait for this whole crowd of minority carriers to clear out of the junction. It's like a microscopic traffic jam that has to disperse before things can stop. But a Schottky diode, Because it's unipolar, it never had those minority carriers to begin with. There's no traffic jam to clear, the path is always open for a nearly instantaneous switch. It's brilliant. Now, as amazing as this little guy is, it isn't perfect. I mean, what is? Like any super specialized component, its amazing strengths come with a few trade-offs. It's important to know what it's not so great at. It really has three main weaknesses. First, it tends to leak a little bit more current when it's supposed to be off. Second, it usually can't handle as high of a voltage in reverse before it breaks down. And finally, its comfort zone, its operating temperature range, is typically a bit smaller than a standard silicon diode. So after all that, what's the big picture here? What's the one thing you should really remember from all this? This scorecard really says it all, doesn't it? The Schottky diode basically trades a tiny bit of leakage current for a massive, massive upgrade in speed and efficiency. And it gets all that from its low voltage drop and its unique metal semiconductor construction. For any application where speed and efficiency are king, it is just in a league of its own. So the next time you plug in your super slim, lightweight laptop charger or really use any high-speed device, you can thank this tiny unsung hero. The Schottky diode really is a fundamental piece of the puzzle that makes our fast, cool, and efficient digital lives even possible. It really makes you wonder, doesn't it? I mean, this one jump from a standard diode to a Schottky diode, it enabled so much incredible innovation. So the real question is, what's next? What new leap in component technology is out there, and what kind of world will that make possible? That's definitely something to think about. Thanks for joining me for this one.